Hi and Asalamualaikum. My name is Syahmi Haqim bin Shamsudin and my matrix number is B0519100048. I would like to present my final year project, which is Optical Monochromatic Light Reflection System to determine coating thickness. And my final year project is being supervised by Mr. Fairuz Dimin, and my panel for this presentation is Dr. Sivarau Anak Lelaki Subramanian, Dr. Nur Izan Syahria binti Hussein, and Miss Nurul Widah binti Mafazi. So basically for this presentation, there are 6 parts, consists of introduction, problem statement, objective and scope, literature review, methodology, result and analysis, and conclusion. What is optical measurement technique? Metal plating thickness measurement using optical method employing the monochromatic red laser light. The intensity of the light is modulated and the phase relationship of the transmitter and receiver signal compared. The velocity of light is calculated from the relationship between the change in the phase and the light path. Change in the distance of the light path will determine the plating thickness. Change in the distance of the light path will determine the plating thickness to 0.001 mm. The method gives high accuracy, repeatability, and increased cycle time of measurement. Current available technique in the market can measure until 0.01 mm. Thus, the advantage of this optical measurement technique is can be employed to any coating substrate or base foundation. As you can see, there are applications for optical monochromatic light, which is red laser, in the industry to determine or to measure the coating thickness. For this project, the problem statement is inconsistency in plating measurement because of human error and equipment error. For the equipment error, the problems that involved in this part is there are some parts in the device that did not fit perfectly. So when measure the coating thickness, it will affect the measurement because the device is very sensitive. Any small changes will give different result. Next, the device also high inspection cycle time, which is it required to calibrate after a single measurement. My target for this project that I want to achieve is I want to design metal plating thickness measurement system with red laser monochromatic light and velocity receiver. Second, I want to improve the accuracy of the plating thickness measurement system to 0.001 mm. And last, I want to improve inspection cycle time compared to the currently technique employed by the industry. Dr. Yang Yu, application scientist in Taylor Hobson University. Thickness measurement is a challenge that affects many scientists and technicians in both academic and industrial environments. The composite material on which metallic coating are applied are ubiquitous and allow one to obtain properties that a single element will not have. Thickness control is decisive for the obtain of definite technological properties, and thus its measurement is necessary. In this review, we describe the primary technique both for preparation and analysis, which are used both in research and the industrial sector for this purpose. In fact, there is no perfect technique suitable for any type of sample, but the most appropriate route must be chosen for every need. Coating thickness measurement. This table provides 5 different methods, which is laser triangulation, laser calipers, laser triangulation with calipers, dial gauge or micrometer, and light transmission. For this project, the flowchart starts with define problem statement, objective and scope. Next, research on literature review. Third, generate design and concept. Fourth, selection of suitable component. Fifth, fabricate prototype. 6. Test and run. 7. Result verified. And last, preparing the report. For the system flowchart, it starts with system calibrate, and then it goes to acquisition spectrum of reference mirror or acquisition spectrum within quad glass, and then next comparison of central wavelength, and proceed to calculate thickness of quad glass, while aberration correction for optical device or error correction for refractive index of multi-light. Okay, we proceed to the next subtopic, which is methodology. Okay, for the product requirement, okay, first, monochromatic red laser. It is stronger laser as it high in power level, measure in milliwatt, great longer range and more vibrant looking beams. Second, laser receiver, to detect the laser beam and distance traveled by the laser. It is function as blocking object. Next, sample measurement holder. It is place the sample between the holder and clamp the sample. It is for the sample stay perfectly when taking measurement or taking the reading. And fourth, cylinder beam holder. Place the beam through the holder and the diameter for beam and the holder is same, so it will fit perfectly. Okay, basically, how the system operate. Okay, the component for the detector is photo IC, IC support board, interface board. When the laser emit to the reflector, it will refract back with diverging. After that, it will through the lens and reflect back with converging and focus to photo IC. Photo IC will detect the laser and give signal to IC support board. We move to the next subtopic, result and analysis. For this project, we conduct an experiment. The procedure of this experiment is we prepare 6 samples. One of the sample is before coating and the other 5 is after coating, but with different thickness and different number of layer coating applied to the sample. From the sample, we take measurement coating thickness with 2 different methods, which is micrometer and optical monochromatic technique by using red laser. So the collected data we can compare and make an analysis. From the analysis we can make a conclusion from this experiment. As you can see right now, this is the data for optical monochromatic technique. To get the coating thickness, you must minus the sample thickness and the before coating thickness to get the coating thickness. After complete collecting data for this method, I'm very impressive about this device as I managed to achieve the objective in this project. And then next, this is also the data for the micrometer. Comparison for these 2 methods. For optical monochromatic technique, it is high in accuracy, which is 0.001 mm. It also high in consistency, but also higher in cost. For micrometer, it is low cost, it is manual, but high inspection cycle time. Okay, for the conclusion, dimension measurement is required to assure top quality of product as per customer specification. Thickness gauge can be contact and non-contact type and use inductance, capacitance, laser technology and beta radiation for measuring the thickness of base materials and apply coating surface. The length of an object can be found by subjecting it to a laser source and thus noticing the shift in frequency of laser beam. Thank you for watching.